Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 5.2, Day 2 notes. Today we're going to talk about how to multiply rational expressions. You want to make sure that you have your list of steps that will help you multiply or divide rational expressions and simplify them. You got that yesterday, okay? So the objective is to multiply rational expressions. A little review here. How do I multiply two fractions? Well, in order to multiply two fractions, I'm going to multiply straight across. So 1 times 2 would be 2 over 4 times 3, which is 12. At this point, we need to make sure that we need to double check and see if we can simplify. Well, 2 can be broken into 2 times 1. 12 can be broken into 2 times 6. I can get rid of the 2's, which would leave me with 1 over 6. That's pretty important because we're going to end up using that same technique to simplify our rational expressions. All right. So for the second fraction, then it's 1 times 2, which is 2. 2 times 3, which is 6. We can do 2 times 1 again. 6 can be broken into 2 times 3. Get rid of the 2's. We end up with 1. Hang on a second. 1 over 3. Okay? On to our other fractions over here. All we're going to do with these is just go ahead and simplify that first fraction. They are both monomials, so all I have to do, I can break them up real quick. So it'd be 2 times y times y times y, because there's 3 y's there. 2 times y. Get rid of 1, 2. Get rid of 1 y. End up with y squared over 2. Okay. On to the final review here. I have x squared minus 9. I want to take this piece by piece. So that first, the numerator, is not a monomial. It is a binomial. So I want to check and see if I can factor that. Well, it is the difference of two squares. So that can be broken into x plus 3 times x minus 3 over x plus 3 cannot be broken up any further, so it's just x plus 3. Get rid of the x plus 3's. That would leave me with x minus 3 as my answer. Okay? We have a definition we need to talk about. A restriction is a value that x cannot be equal to. In fractions, the denominator should never equal 0. So when we talk about restrictions, it's only what x cannot equal in the denominator. I'll show you what that means in 1 second, but let's go ahead and start working through some of these problems first. Problem number 1, I have y to the third times 4y squared, y to the third over 2y squared times 4y squared over 6. What I'm going to do first is go ahead and multiply straight across. So I'd end up with 4y to the fifth over 2y squared times 6 would get me 12y squared. At this point, I have two monomials. According to our steps, if I have a monomial, I can leave it alone for a second. Since it is a monomial, I can drop down to step number 4, which is state any restrictions. What I'm going to do to state restrictions here, my denominator cannot equal 0. So 12y squared cannot equal 0. In order to solve for y, I would divide by 12. So y squared cannot equal 0. Take the square root of y squared. Y cannot equal 0. All right. Anytime you have a monomial with a variable, it's just going to be that variable cannot equal 0 for your restriction. Okay. Now on to breaking up our two pieces. What I'm going to look at is just the numbers first. So I have 4 and 12. Well, 4 and 12 have a GCF. They have a greatest common factor of 4. So I'm going to leave 4 in my numerator. In my denominator, I'm going to take 4 times 3, right? Because 4 times 3 would get me 12. Now, I have 5 y's in the numerator, so I'm going to go ahead and write out all 5 y's. I have 2 y's in the denominator, so I'm going to go ahead and write out my 2 y's. What do I have that's in the numerator and the denominator? Whatever I have in both gets to go away. So the 4's will go away, and 2 of the y's will go away. That would leave me with y to the third over 3. Now what I want you to notice, y to the third is the same thing as if I took 5 minus 2. notice when I take 5 minus 2, I get y to the third. And it goes to where my largest exponent was. So in this case, it was in the numerator. If it was 4y squared over 12y to the fifth, then the y to the third would go in the denominator. So what I'm going to do whenever I want to simplify monomials like that is I can go ahead and just subtract the two exponents. If I subtract the two exponents, then my answer, in this case it was y to the third, will go in either the numerator if that had the largest exponent or the denominator if that had the largest exponent. If you have a question on that, please make sure you ask tomorrow. Okay? Now, on to problem number 2. I have 5x plus 10 times, or over x minus 3 times x squared minus 9 over 5. I could multiply these completely out using FOIL, but instead of doing that, what I'm going to want to do is try to simplify them down as far as I can. So I'm going to take this first piece, 5x plus 10. It is not a monomial, which is our first step to see if it's a monomial. If it is not a monomial, then I'm going to go ahead and factor. My first rule of factoring is GCF, so I'm going to take out a 5 between 5x and 10. That would leave me with x plus 2. Okay? And then the next piece I'm going to look at, I want to do my numerators first. I have x squared minus 9, which is the difference of two squares. Since I have multiplication in between, I can write the factored form of x squared minus 9 just right next to it, because if I have two parentheses attached to each other, that just means multiplication. On the bottom, x minus 3 times 5. I can't do anything more with x minus 3. Can't do anything more with 5. I'm going to go ahead and put my number out front, times x minus 3. Again, anything that's in the numerator, that's also in the denominator, I can get rid of. So I can get rid of my 5s. I can get rid of my x minus 3. I'm sorry. I shouldn't have gotten rid of that x plus 3. X plus 3 should still be there. So this was x plus 2. This is x plus 3. Okay? So I can get rid of my x minus 3's. What's left in my numerator is x plus 2 times x plus 3. The one thing I forgot to worry about, though, real quick, was my restrictions. I kind of always want to do that, or at least I like to do that before I get rid of things. In this case, I did not, and I apologize for that. But this is x minus 3 here. I only need to work with the section that has the variable. So x minus 3 cannot equal 0, which means that x cannot equal 3, because I would have to add 3 to both sides in order to solve for x. Okay? So my final answer would be x plus 2 times x plus 3. Remember, all we're really doing here is just simplifying our rational expressions. Okay? On to problem 3. In this case, I have a fraction times just a binomial. Well, in order to make it a fraction times a fraction, I can always write that over 1. Is there anything I can do with the number 3? There is not, so I'm just going to go ahead and write that. I can do something with 2x plus 2, though, which is take out a GCF of 2. So I'm going to multiply by the 2. If I take that out, it would be x plus 1 all over. Now I have x plus 1 times 1, so it's just going to be x plus 1. Before I continue, remember I want to find my restriction, so it would be x plus 1 cannot equal 0. I'm going to subtract 1 from both sides. X cannot equal negative 1. Now I can go ahead and get rid of anything that's in the numerator that's also in the denominator. That would leave me with 3 times 2, which is 6, and I am done. All right. On to 4, just like on problem 3. If I need to make two fractions, then I just go ahead and put it over 1. So now in my numerators, x minus 3 is the first thing I want to look at. Is there anything I can do with x minus 3 as far as factoring goes? There is not, so it'll be x minus 3 times. How about x plus 3? Again, nothing more I can do with x plus 3. So I just go ahead and leave it like that. Over 1 times x squared minus 9. X squared minus 9 is not a monomial, which means I need to see if I can factor it. It is the difference of two squares, so I could factor that into x minus 3 times x plus 3. Okay? Before I continue, again, I want to find my restrictions. So x minus 3 cannot equal 0. If I add 3 to both sides, then x could not equal positive 3. X plus 3 cannot equal 0. Subtract that from both sides. X cannot equal negative 3. So my restrictions are x cannot equal 3 or negative 3. Now I can go ahead, anything that's in the numerator and also in the denominator I can get rid of. So x minus 3, x plus 3. Well, it looks like there's nothing left, right? Remember, there's always something hidden in front of a parenthesis. It is the number 1. So the 1s technically could go away, but what if I divide 1 by 1 in the calculator? I'm going to end up with, I have 1 over 1, I'm going to end up with the number 1. Okay? On to 5. Remember, go piece by piece here. Don't try to do it all at one time. Go piece by piece. So the first piece I'm going to look at is y minus 5. It is not a binomial or monomial. It is a binomial, which means I need to try to factor it. In this case, I cannot factor y minus 5 any further, so I'm going to go ahead and leave it alone. Then I have 2y squared, which is a monomial, so I can go ahead and leave it alone. Okay. Then I have 3y squared minus 3, or minus 3y. In this case, it is not a monomial, so I need to try to factor it. I can factor this using a GCF, which would be 3y, which would give me y minus 1. Y squared minus 6y plus 5, again, is not a monomial, which means I need to try to factor it. What can multiply to positive 5 and add to negative 6? Well, that would be negative 1 and negative 5. Okay? Negative 1 and negative 5. In this case, now what I need to do is find my restrictions first. So I'd have 3y cannot equal 0. So if I divide by 3 on both sides, y cannot equal 0. I have y minus 1 cannot equal 0. I do not have to write y minus 1 cannot equal 0 twice, just because it's going to end up being the same answer for my restriction, which would be positive 1. And then I have y minus 5 cannot equal 0. If I add 5 to both sides, y cannot equal positive 5. Okay? Again, at this point, what I'm going to do is get rid of anything that's in the numerator that's also in the denominator. So the quick and easy one is the y minus 5. Remember what I talked about on problem number 1. I have 2 y's in the numerator. I have a single y by itself in the denominator, which means I can take y squared minus y, which would get me just positive, or just 1y. So my numerator would be 2y over 3y times y minus 1 times y minus 1. Now, if you did not catch what I just did there, I'm going to write this next piece in red so that you realize it's just showing you what I did from this step to this step. Okay, this would be 2 times y times y. This would be 3 times y minus 1 times y minus 1. Okay, just like we did on problem number 1, that means I can get rid of 1y each, which would leave me 2y over 3y times y minus 1 times y minus 1. Okay, you did not need to write that red piece. That was just the step that I went ahead and skipped, trying to get you to understand that I could just take the 2 minus the 1 in order to keep a single y in the numerator. All right. Problem 6 is just like 3 and 4 in that I need to put 2x minus 3 over 1. So the first piece is the 2x plus 1. It is not a monomial, so I need to see if I can factor it. I cannot factor 2x plus 1 any further, so I'm going to end up with 2x plus 1. I have 2x minus 3. I cannot factor 2x minus 3 any further. Okay. Now I have 2x squared minus x minus 3. This can be factored. Remember, 2x times x, 3 times 1. I need to find some combination of how these could multiply together in order to get me to negative 1. If I take 2x times 1, I end up with 2x. If I take 3, or x, times 3, I end up with 3x. Is there any way that 2x and 3x could get me to negative 1? Yes, there is, if the 3x was negative, which means that that 3 would need to be negative. So now I make two sets of parentheses. The 2x and the 1 work together, so if I have 2x here, I would have positive 1 there. The x and the negative 3 work together, so if the x is here, the negative 3 needs to go there. Now that I have everything completely factored, I need to find my restrictions. So 2x minus 3 cannot equal 0. I would add the 3 to both sides. 2x cannot equal positive 3. Divide by 2. X cannot equal positive 3 over 2. Then I have x plus 1, so x plus 1 cannot equal 0. If I subtract 1 from both sides, x cannot equal negative 1. All right. Anything that's, now that I have my restrictions, I can go back to simplifying my fraction. Anything in the numerator that's also in the denominator can go away. So 2x minus 3 can go away. Now, I do have x plus 1 in that this parenthesis up here. The problem with that is there's a 2 attached to the x. Those have to be 100% the same in order for me to be able to get rid of them. So I can't get rid of anything else. I would end up with 2x plus 1 over x plus 1. Okay? All right. On to the back side. We are going to go ahead and skip number 7 for now. I might have you guys try that as a challenge problem moving forward, but right this second we're going to go ahead and skip problem 7. Okay. Problem number 8. Again, I want to work piece by piece here. So I have x squared minus 2x minus 8. That can be factored. So I'm going to make two sets of parentheses. In the first blank of the parentheses, I have what comes from x squared, which would just be x. What multiplies to negative 8 and could add to negative 2? Well, that would be negative 4 and positive 2. Okay. Now it would be the second numerator, so 3x squared plus 10x plus 8. I have 3x times x. I have 1 times 8 and 2 times 4. I want to get as close as I can to 10 with my first multiplication. So if I take 3x times 2, I end up with 6x. If I take x times 4, I end up with 4x. So if I have 3x times 2, I end up with 6x. If I have x times 4, I end up with 4x. Can 6x and 4x get me to 10x? You bet they can. So two sets of parentheses for that as well. 3x goes in the first blank. That works with 2. So the 2 would go back here. That is a positive 2. And then I have x and 4. So the x goes in the first blank. 4 goes in the second, or the other blank. And I'm good there. All that is over. Now I have 9x squared minus 16. It is not a monomial, so I need to see if I can factor it. Well, 9x squared is a perfect square. I have a subtraction sign, and 16 is a perfect square. So that can be factored. The difference of two squares would leave me with 3x plus 4 and 3x minus 4. Notice that there's something in the numerator that I just found, right? 3x plus 4 and 3x plus 4. That will tend to happen. There will be times that it doesn't, but for the most part, that tends to, at least one of those pieces will come out in my denominator, okay? Now I'm looking at x squared minus 16. Again, x squared is a perfect square. I have a subtraction. 16 is a perfect square. So I'd have x plus 4, x minus 4. The x's come from the x squared. The 4's come from the 16, okay? Now that I have everything completely factored, what I'm going to go ahead and do is find my restrictions. So 3x plus 4 cannot equal 0. If I subtract 4, 3x cannot equal negative 4. Divide by 3. X cannot equal negative 4 over 3. There is a pattern to those, okay? if you can see it real quick, what happens is I have the opposite. My numerator ends up being the opposite of this number. My denominator ends up being the same as that number. Okay? So if we go ahead and use 3x minus 4, what we should end up with is x cannot equal positive 4 over 3. Let's see if that happens. Well, if we add 4 to both sides, 3x cannot equal positive 4. Divide by 3. X cannot equal positive 4 over 3. On to our last two restrictions. X plus 4 cannot equal 0. If I subtract 4 from both sides, x cannot equal negative 4. X minus 4 cannot equal 0. If I add 4 to both sides, x cannot equal positive 4. All right. So my restrictions in this case are x cannot equal negative 4 over 3, x cannot equal positive 4 over 3, x cannot equal negative 4, and x cannot equal positive 4. Now on to simplifying our fraction. Anything that's in the numerator, I can also take out of the denominator. So I have x minus 4 and x minus 4. I have 3x plus 4 and 3x plus 4. So I end up with x plus 2 times x plus 2 over 3x minus 4 times x plus 4. And that is my final answer. Okay. On to our last problem. The factoring here is a little bit easier. I have x squared minus 2x minus 3 in my numerator. That is not a monomial, so I need to check and see if I can factor it. That can be factored. What multiplies to negative 3? That can add to negative 2. Two sets of parentheses. What comes from x squared is x and x. I need a negative 3, and a positive 1 would get me back to negative 2. On to x squared plus x minus 6. Again, two sets of parentheses. X and x come from the x squared. What could multiply to negative 6 and add to positive 1? That means I'm going to have a positive and a negative. I need my larger number to be positive, so positive 3 and negative 2. All of that is over. Now I need to check my first denominator, which is x squared minus x minus 2. Again, that can be factored, so two sets of parentheses. X will go at the beginning. I need this now to be a negative x. It needs to add to a negative x. But since I want to multiply to a negative number, it would be positive, negative. Since x is negative, my larger number would be negative, so 2. And my smaller number would be positive, so 1. The last denominator, x squared plus 2x minus 15. Again, my x's come from my x squared. Now, what multiplies to negative 15 could add to positive 2. Again, since I need to multiply to a negative number, I need a positive and a negative. I want my larger number to be positive because my middle number is positive, so that would be positive 5, negative 3. Before I go any further, now that I have everything all the way factored, I'm going to go ahead and find my restrictions. So if I subtract 1 from both sides, x cannot equal negative 1. I have x minus 2 cannot equal 0. So add 2 to both sides. X cannot equal positive 2. Then I have x plus 5 cannot equal 0. Subtract 5 from both sides. X cannot equal negative 5. And x minus 3 cannot equal 0. Add 3 to both sides. X cannot equal positive 3. Now that I've found my restrictions, which are x cannot equal negative 1, x cannot equal 2, x cannot equal negative 5, and x cannot equal 3, I can go ahead and cancel out anything that's in the numerator that's also in the denominator. X minus 3, x minus 3. X plus 1, x plus 1. X minus 2, x minus 2. That leaves me with x plus 3 over x plus 5. And I am done. Now I know that's a lot of stuff I threw at you there. There's a lot of review on factoring. So that's why you really need to be using that step sheet I gave you yesterday. Okay? You really need to be using that step sheet. Go right down that list until you start getting comfortable with this stuff. Okay? The first step in any of these problems is to make sure everything is factored. Once everything is factored as far as I can get it, then I need to find my restrictions. Once I have my restrictions, then I can go ahead and cancel out anything that's in the numerator that is also in the denominator. Remember, if you have any questions over this stuff, please come and see me. Don't be confused by this stuff, guys, and please don't fall behind. We don't need anybody falling behind. All that's going to do is make life so much more difficult for you. Well, thank you very much for watching the video. Remember, if you have any questions, come see me. Otherwise, have a great day.